Uh, Hello everyone, welcome to yet another video in a series of videos. We shall again be talking about machine learning as applied to triage and prognosis in the medical field. This is the third video, and in this video we shall discuss our project description and the methodology. Just a highlight, so this project is concerned with the Sustainable Development Goal 3, which talks about good health and well-being. And I am presenting together with my colleague, Henry. So we shall discuss the problem at hand and give a quick background about that. Then we shall dive into the significance of our proposed work and its scope, quickly touch on some research questions, present our hypothesis, present our objectives, describe the data that we intend to use, and then go through our machine learning methodology and implementation workflow. Then we shall wrap it up with a couple of references. So at this point, I'd like to hand over to Henry to take over the discussion.
Yeah, thanks, Alvin. Straight into the problem at hand. There's been dire need to improve the triage process at emergency departments within hospitals, and this is because it's a very time critical process and could lead to dire effects if mistriaged. So triage is basically categorizing of patients and prioritizing them based on their condition, and we intend to use machine learning techniques to build models that can easily be deployed in, say, decision support systems for hospitals to enable to improve the efficiency of this triage process. And we intend to use a data set that has historical data about the patients, but also their symptom data in order to predict certain triage classes. Yeah, and then also in addition, our study will not stop at predicting these classes, but also we intend to identify or understand the relationship between the characteristics in the data for the patients. Now, as a background, emergency departments are really resource constrained. And this is in terms of the personnel, in terms of bed space, but also equipment. And then yet they face ever increasing numbers of patient visits. So that has led to a gap that triage seeks to fill, whereby we need to find out, okay, which patients should we give more priority to, because the resources we have are really not that much. Yeah. So now the triage process has evolved, and back then there was the traditional triage, which involved physicians or nurses or doctors actually carrying out triage themselves, and based on their historical knowledge or their professional knowledge, they're able to categorize patients. But this was really prone to errors. And from that, other techniques have been proposed. Now, we want to propose machine learning techniques to use this historical patient information, and solve some of the challenges that come with, human intervention in this process. Yeah. And then the significance of our study: one, we want to reduce the time spent during the triage process, and also reduce the human error during the process, because the traditional process involved a lot of the nurses, and maybe they could have some unconscious bias, maybe when they're tired. So we want to reduce some of those errors. But then also, previously, machine learning has been underutilized in this area, where they just predict, the triage value, or the triage value. Now we want to take this step to the next step in our project by looking at the common characteristics and relationships in the patients within the emergency department, and then see how does machine learning triage affect the outcomes of these patients, and try to explain those. Yeah. but then also we want to maintain the human in the loop. So our project will not, or our models will not eliminate the nurses or the doctors, but we intend to build models that can be put in decision support systems so that they can work with them for a better or a more efficient triage system. Now, the scope of our work is adult patients, adult visits in the emergency department, and this is defined by the data that was collected. So we're not looking at the infants or the youth, but just adult visits. Then some of the research questions we seek to answer are listed below. One, is it possible for machine learning to automate the triage process? I want to understand that, or to what extent, like the last question. Then what is the effectiveness of triaging to a certain emergency condition? So these patients come with different conditions and we have to triage them. So we want to understand, are there certain conditions that are triaged better or more efficiently than others? Then how likely is machine learning able to improve a patient's prognosis? We also want to understand that. Then can machine learning be employed to improve patients' adherence to healthcare planning? Yeah, it's a question we want to understand. Then if machine learning, we also want to understand if machine learning methods can improve the triage process, and also how this affects the prognosis. Prognosis is basically the stage after you have gotten out of the hospital. And then what are the biases and ethical implications of applying machine learning during the triage process? So these are things we seek to understand, and I'll hand over to Alvin to take us deeper in this.
Yeah, thanks, Henry, for that discussion and background. So I'll pick right off from the hypothesis that we present to you. So it states that, can we use machine learning to, one, predict the emergency severity index of a patient, and then go on to predict a patient's outcome, basically prognosis analysis. And then given all that, can we as well use machine learning to determine the effect of ML triage on patients in the emergency department, or on patient outcomes, as well as can we find characteristics and relationships within patient medical history and medical data that can be used to generate insights that can support human in the loop machine learning triage of patients in emergency care. So what are the objectives of this work? Given the hypothesis, we have 4 key objectives. We want to predict the emergency severity index, the ESI of a patient. We want to predict patient outcomes in the emergency department. We want to be able to evaluate the effect of implemented machine learning triage systems on the anticipated patient outcomes. And then finally, we want to generate knowledge and insights that can support human in the loop machine learning triage in emergency care. So those are the 4 key aims of the work that we present here today. And the data that we shall use, the data that supports our implementations, is captured from adult visits to the emergency department from 2014 to 2017. So it covers around 5,000 plus patients, walk-in patients, and it captures about 900 plus variables of these patients. So these variables consist of personal information, patient medical history, and then vitals that were captured through the triage process. So personal information can be name, demographic, that is maybe your age and so on and so forth, or your race, gender, then your location. Then we look into your medical history. Let's say, do you have a history of diabetes, stroke, do you have a history of cancer in the family, and so on and so forth. And then vitals that are captured throughout the triage process. So for example, what's your heart rate, what's your breathing rate, what's your chief pain complaint, and so on and so forth. So these are just a quick summary of some of the features that are incorporated in the data set that will be key to the work that we're trying to do. And our proposed methodology for the implementation of this work follows 5 steps. So obviously the first step is some analysis of the work that's already been done and diving a little deeper into the limitations of those works just to uncover possibilities for further research. Then upon that, we would like to dive into machine learning modeling to support or to implement or to prove our hypothesis. And we shall be doing machine learning modeling in two phases. So we shall first undertake unsupervised learning, incorporating things like logistic regressors, random forests, and artificial neural networks to take on the supervised task or the classification task of predicting the emergency severity index of a particular patient, as well as the patient's outcome. Then the second ML task will be to use unsupervised learning, such as clustering, to find common characteristics and groupings of patients, and then principal component analysis to understand the complex feature space that we have previously defined. That is, the 900 and plus medical features in our data set. We would like to as well incorporate network modeling to find relationships between these different groupings of patients and triage classes as such. Of course, after modeling, we'd like to refine and improve our models, so do some parameter tuning and then do some internal evaluation as well. So comparing the different models against themselves to find which one performs best. And then we'd need to do some sort of external validation as well, using a holdout test set that wasn't part of the development process, as well as comparing to some baseline models that were developed earlier. Of course, finally, we would like to document and present our results. That nearly sums it up. We've come to the end of this video. These are just a couple of references that supported